In this video, we're going to learn how to do binomial expansion, and we're going to use these three examples to do that. So let us start with part A. Part A, you've been given to expand x plus 4y, and that is raised to power 3. So we're going to use the Pascal's triangle to obtain the coefficients for this expansion. And to know the row that you're going to require, just take n plus 1. So in our case, n is 3. So it is 3 plus 1, which is 4. So it means from the Pascal's triangle, we are going to require the fourth row. So let us generate the Pascal's triangle. So when the coefficient is 1, when the power is 0, that is, the coefficient is 1. Then when it is 1, it is 1, 1. And then you take 1 plus 1, that is 2, then 1 and 1. 1 plus 2 is 3. 2 plus 1 is 3. Then 1 and 1. So that is the fourth row that we're going to use in the expansion for part A. So let us go ahead and list the coefficients that we have. So you just list them as the coefficients. Then you have 1, 3, 3, and 1. The next thing is to observe how the powers of A change across the expansion. In our case, A is x. So the powers of A normally decrease from n to 0. So it means you're going to have x power 3, x power 2, x power 1, and x power 0. Then you also look at how the powers of B change across the expansion. In our case, B is 4i. So you have 4i. So the powers of B normally increase from 0 to n. So you want to have 4i raised to power 0, then 4i raised to power 1, then 4i raised to power 2, then 4i raised to power 3. So you're going to have to simplify this. So 4y raised to power 0 is 1, 4y raised to power 1 is just 4y, and 4y raised to power 2 is 16y squared, and 4y raised to power 3 is 64y raised to power 3. So the next thing from here is just to multiply down. So you take 1 times x power 3 times 1, which is just x power 3, plus the next, that is 3 times x squared times 4y, which will be plus 12 x power 2 y. Then the next one, you're going to have 3 times x power 1 times 16, that is 48 x y power 2. And finally, we have 1 times 1 times 64 y power 3, which is just 64 y power 3. So that is the expansion for part A, which was x plus 4y raised to power 3. For part B, we have x minus 1 over x raised to power 5. So the first thing, we're going to know the row in the Pascal's triangle that we're going to use for your coefficients. So n in this case is 5. So the row number is n plus 1. So that is sixth row. So it means we're going to generate the Pascal's triangle up to the 6th row. So let us do that. So we have 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, then 1 plus 4, that is 5, then that is 10, that is 10, and that is 5. Then you have 1 and 1. So we have 1, 2, 3, 4, 5, 6. So this is the row that we're going to use for the coefficients of this expansion. So we're going to write that the coefficients are 1, 5, 10, 10, 5, and 1. The next thing, we're going to observe how the powers of A change across the expansion. So A in our case is x. So the powers of a normally decrease from n to 0. So it means you're going to have x raised to the power 5, then x raised to the power 4, then x raised to the power 3, then x raised to the power 2, then x raised to the power 1, and x raised to the power 0. The next thing is how the powers of b. In our case, b is minus 1 over x. So let us see how they change across the expansion. So we're going to have minus 1 over x here. So the powers of b normally increase across the expansion from 0 to n. So we're going to have minus 1 over x raised to the power 0, then minus 1 over x raised to the power 1, then minus 1 over x raised to the power 2, minus 1 over x raised to the power 3, minus 1 over x raised to the power 4, and minus 1 over x raised to the power 5. So we can simplify this. Minus 1 over x raised to the power 0 is 1. Minus 1 over x raised to the power 1 is minus 1 over x. Minus 1 over x squared is 1 over x squared. And this one will be minus 1 over x cubed. And this will be 1 over x power 4. And this is minus 1 over x power 5. Remember, when the power is odd, the negative is maintained. When the power is even, like 2, the negative disappears. We have a positive value. So the next thing is just to multiply these down. So we have 1 times x power 5 times 1, which is just x power 5. Then you have 5 times x power 4 times minus 1 over x, which will be 5 x power 4 over x. Then we have 10 times x cubed times 1 over x squared, that is plus 10 x power 3 over x power 2. Then we have 10 times x squared times negative 1 over x cubed, that will be minus 10 x squared over x cubed. And then we have 5 times x times 1 over x power 4, which will be plus 5x over x power 4. And then you have 1 times minus 1 over x power 5. That is minus 1 over x power 5. So we can simplify this further, so that we have, this is x power 5 minus, this is 5x cubed plus this is 10x, and this is minus 10 over x, and this is 5 over x power 3 minus 1 over x power 5. So that is the expansion for x minus 1 over x raised to the power 5. So let us go to part C. So part C, we are required to expand x minus y power 5, and we're required to use that expansion to solve the value of 1.98 raised to the power 5. The first thing is just to get the expansion of x minus y power 5 just the way it is. And then we compare the two values. We write the numerical as a binomial, that is something plus something. So let us first of all expand this. So if from the Pascal's triangle we can obtain the coefficients, and just like in the previous example, these should be 1, 5, 10, 10, 5, and 1. So the other one is to check how the powers of x change across the expansion. So it will decrease from power 5, power 4, power 3, power 2, power 1, and power 0. Then you also look at how the powers of minus y change across the expansion. So at the beginning, it has got power 0, then power 1, then power 2, then power 3, then power 4, then power 5. So we can simplify this to be 1 minus y squared minus y cubed, y power 4, then minus y power 5. So from there, we can now just multiply down. So we have 1 times x power 5 times 1, which is just x power 5. Then you have 5 times x power 4 times negative y, that will be minus 5 x power 4 times y. Then we have 10 times x power 3 times y squared, that is plus 10 x power 3 y squared. Then we have 10 times x squared times minus y power 3, that is minus 10 x squared y power 3. Then you have 5 times x power 1 times y power 4, that is plus 5 x y power 4. Then you have 1 times 1 times minus y power 5, that is just y power 5. So this is the expansion that we have for the binomial that you are given. So now we want to use this to solve the numerical 1.9 raised to power 5. So remember what we had was x minus y raised to power 5. So we're going to compare this with 1.98 raised to power 5. So what we need to do is write 1.98 as a binomial. So it would be 2 minus 0.02 raised to power 5, or it could be even 1 plus 0.98 raised to power 5. So remember, the value has not changed even if you wrote it as a binomial. But you need to write it as a binomial for you to be able to compare it with the binomial that you've been given. That is x minus y raised to power 5. So I'll go for the first option because it is straight. We have a negative with a negative, and the values involved are straight. So for us to evaluate this, we're just going to compare these two. So we're going to have x minus y, and we compare that with 2 minus 0.02. So what this means is that x is equal to 2. So we have x equal to 2 and y equal to 0.02. Y equal to 0.02. So all we need to do is just substitute these values for x and y in this expansion. So we have x power 5, so that is 2 power 5 minus 5 into x. X is 2, and that is to power 4, and then y is 0.02 plus 10 into 2 power 3 into 0.02 power 2 minus 10 into 2 raised to power 2 into 0.02 raised power 3 plus 5 into 2 into 0.02 power 4 minus 0.02, and that is raised to power 5. So if we simplify, or if we evaluate each term in this sum, we're going to have 2 raised to power 5 is 32. So we have 32 minus 5 times 2 raised to power 4 times that, we're going to get 1.6. Now plus 0.032 minus 0.00 0.032 plus 0.00000016 plus, and that should be minus because it was a minus there. So we should have that is minus, that should be minus 0.12345678. That should be 8 zeros. So 0.1234567832. Then we just find that the final value for this is 30.4316 which is approximately 30.43. If you find this video useful, please like, share, comment, and don't forget to subscribe.